A 19 mm diameter steel rod having Young modulus equal to 200 gigapascal is required to absorb the energy of a 25 kg collar that falls through a height h is equal to 75 mm as shown in the figure. Determine the minimum required rod length L so that the maximum stress in the rod does not exceed 210 megapascal. So we have diameter is known here, value of h is known, length you have to find out, height h is known, even the weight of the collar is known, and the maximum value of a stress, that is sigma impact, is known. So diameter is given as 19 mm, h is given as 75 mm, Young modulus is 200 into 10 to the power 3 megapascal. Mass of the collar, that is a moving load, is given as 25 kg, and maximum stress is same as the impact stress, and this value of the impact stress is given as 210 megapascal. Know that the DL impact is same as equal to sigma impact divided by Young modulus multiplied by L. And if we apply here the work energy principle, that is the change in kinetic plus change in potential energy equal to strain energy, change in kinetic is equal to 0, that is known to us, change in potential is equal to same as equal to h plus dl impact. So this value of dl impact is unknown for us because length is not known. On the right hand side also the length is not known, so there are two unknown in this equation, so you have to skip the step of work energy principle. The second route for us is to find the value of impact factor, which one is given as the impact stress divided by static stress. Out of that we know the value of impact stress, that equal to 210 megapascal. Static stress we can find out m into g divided by area. Area is indirectly known to us, so we can find out here impact factor. Once we calculate impact factor, then we can calculate dl static, and dl static is same as sigma static multiplied by L divided by Young modulus. So we can take our step like this. So before you find here the value of impact factor, let's calculate here first what is the static stress. So we have static stress sigma s is same as equal to m into g divided by area A. Mass is given as 25 kg. So we have 25, acceleration due to gravity is 9.81, and diameter is given. So we'll use the formula pi by 4. So 4 will shift in numerator, and we have diameter is equal to 19 mm. So we have 19 square of it. Using this we can calculate sigma static. So sigma static come out to be 0.864 megapascal. So very small stress is developed due to static loading. Now we know the value of impact stress, static stress, so we are able to calculate impact factor. So we have impact factor equal to impact stress equal to 210, and we have static stress equal to 0.864. So approximately we are getting here the impact factor equal to 243. At this stage we'll use the second formula and we'll calculate here dl static. So we have impact factor equal to 243 is equal to 1 plus we have under root of 1 plus 2 times of h, and we have h is equal to 75 divided by the deformation due to static loading. Solve this and find out the value of dl static. So you will get a value of dl static equal to 0.00256, that will be mm. But the dl static is same as equal to sigma static multiplied by length L divided by Young modulus, that is strain multiplied by length L. So we have length L equal to static deformation equal to 0.00256 multiplied by Young modulus in megapascal is given to us is 200 gigapascal, is 210 to the power 3 megapascal, divided by the static stress equal to 0.864. Solve this, we will get the length L, and we will get the length equal to 593 mm. So while solving the problem, first you try for work energy principle, check your data. If you fail, then you can go to the second side solution, that is finding the value of impact factor, and then you can calculate here dl static as sigma s into L divided by Young modulus E. An object of 100 Newton falls by gravity through a vertical distance of 5 meter, that is h is known. Then it is suddenly stopped by a collar at the end of vertical rod of length L equal to 10 meter. Diameter of the rod is 20 mm. Top of the bar is fixed rigidly. Young modulus is given as 200 gigapascal. Maximum stress in the bar due to impact we have to find out. So this figure shows a movable load before impact and movable load is touching to the collar after impact. Height h is known here. The vertical distance is given as 5 meter. Movable load W is given as 100 Newton. Young modulus also given. The vertical rod length L is also known, that equal to 10 meter, and diameter is given as 20 mm. Maximum stress we have to find out. So let's collect the data here. We have movable load W is equal to 100 Newton. Height h is equal to 5 meter is 5000 mm. Length equal to 10 meter equal to 10,000 mm. Diameter equal to 20 mm. Young modulus equal to 200. Sigma impact we have to find out, that is the maximum stress. So I'm giving you here which step is better step here. Suppose I apply here the work energy principle, then we know that the change in kinetic plus change in potential is equal to U. Now change in kinetic will be equal to 0 because initially and finally we have velocity equal to 0. Initial potential energy corresponds to this position, which one is h plus dl impact. Now this value of dl impact is unknown to us. On the right hand side, the strain energy is given as 1 by 2. The stress due to impact square multiplied by A L by E, and this value of the impact stress also not known. So there are two unknowns. So let's skip this step. The second route is shown here. We can calculate here the impact stress if you know the value of impact factor, and the static stress. Static stress we can calculate as W divided by A. W is known, diameter is known, so we can calculate W by A. So this one is our first step. And then we require here impact factor. For impact factor we have 1 plus under root of 1 plus 2 times of h. H is known here. DL static we required. So this one is our step number 2, that is DL static. So if you know the sigma static, DL static, then our step number 3, and then finally using the step number 4 we can calculate here impact stress. So this is my route. Step number 1 is sigma static, step number 2 is DL static, is impact factor, and the step number 4 is sigma impact divided by sigma static. So write the step here and then start the reverse calculation. First we calculate here sigma static, which is W divided by A. In this case we have load is given as 100. Area is a circular section, so we have pi, and 4 will shift in numerator divided by diameter square, and we have given the diameter equal to 20, and we have to make a square of it. So first calculation is done for sigma static. This value of sigma static come out to be 0.318 megapascal. Now we'll calculate here DL static. DL static is same as sigma static multiplied by length L divided by Young modulus E. That will be equal to 0.318. Length is given as 10,000. So we have 10,000 divided by Young modulus, which is equal to 200 into 10 to the power 3. This answer will come in mm. So we'll get the value of DL static is equal to 0.0152 mm. Now we are ready with impact factor. Impact factor is given as 1 plus we have under root of 1 plus 2 times of h. H is given as 5000 divided by DL static. DL static equal to 0.0152. So we'll get the impact factor is close to 812.1, which is supposed to be very high value. Once we know the impact factor, we can calculate here the impact stress. So we have impact stress, that is the maximum stress, is equal to impact factor equal to 812.1, and we have static stress is equal to 0.318. Solve this. Is approximately equal to 258 megapascal. This stress is very high stress as compared to static. What will be the maximum stress induced in a shank of a horizontal bolt when the head is subjected to an impact of concentric weight W? That is shown in the figure, and this weight is moving with a velocity equal to V at the given instant. Neglecting the bending due to the weight W and the stress concentration, we have to find out here the expression for the maximum stress, that is the impact stress we have to find out. So this position refers here before impact, and after impact the load will come here, and when the load will come here the velocity will become 0. So initial velocity of the load will be equal to V, final velocity V2 will be equal to 0. This time we have Z1 is same as equal to Z2 is equal to 0 because there is no change in potential energy. So this type of problem can be well solved by using the work energy principle. So if we apply the work energy principle and we neglect the energy dissipation in the form of heat and sound, then we have delta kinetic plus delta potential is equal to strain energy U, which is given as 1 by 2 sigma impact square multiplied by A multiplied by L divided by Egg modulus E. This time the change in potential energy will be equal to 0. Change in kinetic energy we write as initial minus final. So on the left hand side we write here 1 by 2. We have mass equal to m, initial velocity equal to v square, final kinetic will be 0, and the change in the potential is also equal to 0, and we have to solve for sigma impact. So half on both sides will be get cancelled. So we have impact stress square will be equal to mass into velocity square multiplied by Egg modulus E divided by area multiplied by length L. Now here the mass we can write as W divided by G. So that adjustment we'll do for M, which is W by G, and we'll write the expression for sigma impact. So this side we have V, then we have under root of mass is replaced as W divided by G multiplied by we have Young modulus and divided by area as well as length L. So we have W into divided by GAL and multiplied by V. V into GL, no, it is V into W into E divided by GAL. Choice A is correct choice. A 32 mm diameter rod AB, as shown in figure, has a length of 1.5 meter. The rod is made up of a bronze having Young modulus equal to 105 gigapascal and has a yield stress of 330 megapascal. The collar C here moves along the rod at a speed of 3.5 meter per second until it strikes the rod end at B. If a factor of safety of 4 with respect to the yield is required for the maximum normal stress in the rod, determine the maximum allowable mass for collar C. He says that the yield strength is given as 330, factor of safety is equal to 4, so maximum stress we can calculate due to impact will be SYT divided by factor of safety, and that value you have to use for design purpose. We have given here the diameter equal to 32 mm, length is given as 1.5, Young modulus is given as 105 gigapascal, it is 105 into 10 to the power 3 megapascal. SYT is given as 330 megapascal. Factor of safety FOS is given as 4. So in this case the maximum stress allowed will be same as the impact stress, and this value of impact stress will take as SYT divided by factor of safety FOS. SYT is equal to 330, factor of safety is equal to 4, so impact stress will be equal to 82.5 megapascal. Now this problem can be solved by the work energy principle. So initially we have collar at this position and finally the collar will come to this position. So this value of 3.5 is our V1 value, and finally we have velocity will be equal to 0. There is no change in the potential energy, So we have Z1 is same as equal to Z2 equal to 0. So all this problem, my steps are standard. First I apply the work energy principle. If it will fail, then I will go for second step. Now here the change in kinetic energy we can very well calculate. Change in potential energy will be equal to 0, and we have strain energy is same as work done is given as 1 by 2 the impact stress square multiplied by area multiplied by L. Area is known, length is known, angle modulus is known, so this side is known to us. Now delta kinetic will be same as half mv square, so we have 1 by 2 m into v1 square. Final kinetic will be equal to 0. Change in potential is equal to 0. So this is how you have to solve this equation. But left hand side here is a SI unit, so you have to prefer the right hand side is also equal to SI unit. That care you have to take. So first of all 1 by 2 and 1 by 2 will cancel out. Mass we have to find out. Velocity v1 you have to take in meter per second is 3.5 meter per second. You have to make a square of it. On the right hand side we have impact stress. This value of impact stress now will come in Pascal. Area you have to take in meter is pi by 4. Diameter you have to take it meter. Meter 32 mm is 0.032 meter, and you have to take a square of it. Length you have to take in meter, that equal to 1.5 divided by the angle modulus. Angle modulus you have to take in Pascal, that is 105. Giga is 10 to the power 9, that is Pascal. So this is the only restriction in this problem. On the left hand side we have SI unit, so strictly you have to use the SI unit. And if you solve it, you will get a mass here, and the value of the mass is come out to be 6.38 kg. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.